So, and I'll be presenting it from a Canadian perspective too, because I am here in Canada. But most of the issues are the same all over the world. And so, of course, COVID's not over, and we have long COVID, but we have additional pandemics that are going to be coming. And when COVID first came out here, it had a 3% mortality rate. The next one could be 30%, 10 times worse. And if we look at susceptible populations like in healthcare, we have 10% mortality rates. So we already have very serious pandemics where we need very serious respiratory protection, even though it's largely ignored in a lot of areas. Our next pandemic could come from a lab leak, it could come from terrorism, and it could come from war. And then we have a new scourge, with climate change. We have wildfire smoke. So even though Lydia's slide showed Canada as #1 in air quality, it certainly was not in 2023, where we had 15 times more forest burn this year than our 10-year average. And so we apologize to our neighbors to the south and our neighbors to the east, who all had to breathe our smoke coming from our forests here in Canada. Sorry, Europe, and sorry, States, but not all our fault. And then, of course, we have issues where our respiratory protection is going to be subject to supply chain issues, especially for geopolitical reasons, right? We have concentrations of production around the world of both the raw materials, whether it's oil that gets turned into plastic, for example, or whether it's the plastics themselves or the finished goods themselves. And then they have to be transported around the world. So local is really where we need to go for the future, both for domestic security for each country, but also for planetary reasons as well. So we need better protection than what we've had, and we need it locally wherever possible. The thing we really need, we need standards for the general public. Right now, all of our respiratory standards for respirators are occupational health and safety standards. And so if you are employed by someone who has a business who has to have a respiratory protection program in place, you may or may not get a respirator, but those standards are written for you. So they're written for adults, they're not written for children. And they're not written for people that are retired. They're not written for self-employed people. They're not written for the general public. And we need to change that. We need global standards and national standards for the general public, specific for infectious disease, as opposed to particulate standards, which I'll talk about in a minute. Healthcare co-opted a lot of the occupational health and safety standards around the world, where they decided we're going to only wear a medical mask or maybe not mask in a healthcare facility, as opposed to following occupational health and safety standards and regulations around the world. So there's some tension there. We have to consider the impact on the economy. Better masks, better respirators are better for the economy because now you can open more. The alternative really, if you've got a very serious high mortality rate disease, is lockdown, which devastates all economies. If you can't have travel, if you can't have tourism, if you can't have hospitality because you do not have good respiratory protection, that's very serious. So here in Canada, it was about $1 trillion hit to our economy, the mismanagement of our pandemic response. That was completely unnecessary. PPE wouldn't have been 1/100th of 1% of that, proper PPE. And so we really need to plan ahead for the future. Every country does. We have to consider the environmental impact of the products that we're using. And of course, we have to write our standards in consideration of future innovation. So we can't lock them into very specific requirements that are not performance-based. We have to focus on the performance or what it is that we're trying to achieve. So comfort and convenience, we need more people wearing respirators, for example. We have to get the cost down, environmental impact down. They have to be decent looking. If we want kids or, people who are going out in the town to wear them, they have to look good. And really, quite frankly, the ones that we have now don't. They look medical or they look industrial. They don't really fit most fashion, or most fashion masks are not effective. So we have to fix that. And then we have to consider people's lifestyles. If they want to go to a restaurant, for example, how can you eat and drink? Or if you want to be 12 hours on a plane, fly halfway around the world, how can you hydrate safely? with respiratory protection. So here's our environmental impact of single-use plastics. It's an absolute disaster. It ends in, lakes, rivers, streams, and oceans all around the world. Here in Canada, we have said we want to ban single-use plastics by the year 2030. And these half dozen products were already banned for this year. And of course, medical masks and respirators, what are we going to do by 2030? So local is going to be better always. Plant-based is better than petroleum-based plastics, and reusable, of course, are best as far as carbon footprint goes. So right now, when we make a mask, typically that oil is pulled out of the ground in Saudi Arabia, gets put onto a tanker ship, gets floated to China, gets made into plastic beads, gets trucked over to a plant that makes some fabric, gets trucked over to a plant then that makes some finished goods, gets trucked over to a port, gets loaded onto another ship, floats the rest of the way around the world, ends up, coming in the western side of Canada, gets put on a train or on trucks and delivered to the central part of Canada where most of the population is, distributed into other warehouses, et cetera. So that's gone most of the way around the world. And there's been a lot of geopolitical potential interaction along the way as well. So environmentally, that makes no sense. Domestic supply chain and national security, et cetera, it just makes no sense to be doing that. So local here in Canada, we could actually produce the plastic from natural gas rather than oil, which is one step better, not a lot, but partly, better. And we're not shipping it all the way around the world. So it's more secure and less environmental impact. Better yet, we can use plant-based sources to make plant-based plastics, which are better yet. And so while the plants are growing, they're pulling carbon out of the air. End of life, preferably recycled back into PPE or other high value products. And if worse comes to worse, industrially composted. But still better than pulling carbon out of the ground and then releasing it later. So reusables are just more protective and environmentally friendly, et cetera. And there's just hardly any reason why we're not using them in areas, where you have to wear respirators all the time. Why aren't they reusable? Makes no sense that they're not. We have medical masks, which are primarily for source control. They're not very good at protecting us, but they could be better than what they are. And then we have the other path, which are respirators, which have traditionally just been too hot and uncomfortable and hard to breathe through. And that's because they developed in two totally different ways. We had the medical path were always easy breathing, and then the industrial products were hard to breathe through. They both started out as reusable, one fabric and the other, rubber elastomeric based. And then, they evolved separately and had separate standards. And then the industrial ones got chosen to provide respiratory protection for disease in the mid-90s for tuberculosis. And so we took the hard breathing products, particulate respirators designed for the coal mines, and decided to give those to healthcare workers to protect them against TB. Well, that was a mistake. We should have continued on this easy breathing line and sealed those masks to begin with. And I'll show you a little bit behind that. So here in Canada, we just came up with a brand new standard for respirators. Here's the NIOSH standard at 245 pascals. That's hard to breathe through. And we introduced two easier breathing categories. Sub 100 pascals is very easy to breathe through. But if we were to go with a disease-specific respirator or a bioaerosol respirator, we could get down as low as 50 or 25 pascals, almost like it's not there. 10 times easier to breathe through than the products that have been traditionally manufactured. And that's really where we need to go to. Half the filter material, half the waste. We've contemplated here the idea of going to a really simple category of bioaerosol 1, bioaerosol 2, and bioaerosol 3, all the same filtration level, just difference in the seal and the convenience of putting them on. So here's where we started in the mines. We're trying to protect yourselves from inorganic, dense rock particles. And here's what we're trying to protect against with COVID and any other airborne disease. So watery, lightweight particles that are sticky versus sharp shards that are very dense. And our tests were developed differently. So the respirator test was developed with salt which is similar in density to the rock dust, whereas the medical mass tests were developed with latex, which are similar density to bioaerosols. So then if we look at the actual sizes of the bioaerosols that are coming out as I'm talking or speaking or shouting, and then we look at where most of that viral load is being carried, and then we look at how filters work, and we say, okay, well, there's electrostatic charge. Everybody knows that. There's diffusion, there's interception and impaction. And so depending on the size of the particle will depend on how significant each property is. And you can see that when you get down into the very small range where we test for respirators right now, electrostatic rules. And so does diffusion. And yet we're testing with products that are 2.5 times more dense than the products we actually want to capture. And we're testing against ones that are very much smaller than the products we're trying to capture. Virus particles that we're concerned about, typically 0.5 to 5 is the range that are carrying most of the virus particles. Here's our bimodal distribution for most of the bioaerosols. And so we are breathing through products that are way too hard to breathe through for what we actually need and are harder on the planet.
Hey, Barry, just a quick heads up. 1 minute remaining, please.
Okay. So as far as our standards go, we started out just with industrial applications. We started to add in medical, first country in the world to do that when we started seeing disease. And of course, for future, we have to consider the public, wildfire, smoke, et cetera. We're specifically addressing healthcare to make sure that it doesn't get co-opted away from the occupational health and safety side of things. And we're specifically going to address in the future the idea that faces are smaller in healthcare and the general public than big guys that work in the mines. And so that needs to be addressed. Easy breathing, something that's comfortable, multiple sizes. You can get easy breathing products now. You can get plant-based products now. You can get masks that you can shape and seal better now, so you can get a well-fitting. And that's really where we need to go. Particulate respirator standards separate from bioaerosols, as well as wildfire smoke. The big difference with smoke, of course, is the chemicals that can be attached to particulates or have a separate gas phase. And really, that's it.
Thanks very much, Barry. You've given us a lot to think about there, a lot of challenges, but also some pretty obvious opportunities to be going after.